Okay, if this is your first time seeing ANOVA, what ANOVA does is it compares three or more groups at the same time to determine if the means are unequal in some way. Okay, so there's different options for how that can happen, but the null hypothesis of an ANOVA test would be that means are equal to each other. The mean of group A is equal to the mean of group C, it's equal to group C. What we're trying to test, or what we're trying to find evidence for, is that at least, we can't even really do this in symbols, we say in words, at least one mean is different than the others. Okay, could be more than one mean. Could be like one mean is significantly higher, one mean is significantly lower. There's further testing you could do. But what would be the correct setup for the null alternative hypothesis for this ANOVA test? These nulls look good. Oh, actually, one has just 4 means, one has 5 means. An analyst wants to set up a hypothesis test to determine if there's a difference in average weekly salaries of 5 groups. So that means we got to exclude this one up here, okay? And then this is the correct order of the null and alternative hypotheses that we talked about, okay? Remember, the null hypothesis is like the no effect model. So if everyone's equal, then nothing's really happened. There hasn't been any changes. Okay. Same test. The economist randomly selects customers from each of the carriers and collects data on the cell phone bill charges. So that's good. That's one of the conditions of ANOVA. You want to try to make sure that each sample is randomly selected and they're independent of one another. Okay, that means picking one person for the test doesn't influence picking another person. Like, you wouldn't want to just pick a group of homes or like one neighborhood and pick a bunch of people from the same neighborhood, because that wouldn't apply for every customer in the every customer that the carrier services. Okay, so basically, random, having everything be random is something that we want. Assuming the populations have equal variances, that's something that we assume with ANOVA. Okay, there's other tests where the variances are unequal, but with ANOVA, we assume the populations have equal variances. We need to determine if the conditions needed for conducting a hypothesis testing in ANOVA are met. Okay. And they even summarize the conditions for you below, so I guess I could have just pointed these out instead of saying all of them. Okay, so let's go through each of them. Each population from which a sample is taken is assumed to be normal. It is determined that the populations have a skewed distribution. So right there, that first of the 5 conditions that Newton lists out is violated. Okay, we have to say no. Each population needs to be normal. If it's skewed, that means it's skewed left or skewed right. Like precipitation looks something like that. I don't have a variable off the top of my head for this left skewed distribution. Those aren't exactly normal because there's a left or a right skew to them. So we have to say no. The conditions are not met. Let's see if there's any other parts. I guess that's it. That's it for that topic.